Well, good evening, everybody. My name's Steve Wilkes. I'm one of the Pro-Vice Chancellors here at Swansea University. And it gives me a great pleasure to be able to extend a warm welcome to you all on behalf of the university and also on behalf of the College of Engineering, particularly on this fantastic Bay campus. Today marks a special occasion, not only for our speaker, but also for the College of Engineering, as this is the first in a series of centenary lectures that will be given to commemorate our 100th anniversary of the university this year. But tonight really is a time to celebrate. It's to celebrate an important personal milestone of Professor Nick Lavery. And it's a time and opportunity for us to celebrate also with family and with friends, with mentors and colleagues. Now, being awarded a personal chair and the title of professor is a demanding process where the university expects very high standards of academic rigor in teaching, research and leadership, particularly looking at an international influence in those areas. Now, Professor Nick Lavery's research interests are largely defined by a varied career between industry and academia, evolving from a modelling background through to postdoctoral positions in engineering. Now, I am assuming, Nick, that the modelling is behind a computer screen and not stood on a catwalk.
A little bit of both.
So a five-year transformative period for Nick was as an exploitation expert in the European Space Agency in Holland. And this really propelled him into the area of materials engineering. During this period, he worked on many major European funded projects, for example, AMAZE, which stands for Additive Manufacturing for Zero Waste, and accelerated metallurgy involving rapid alloy prototyping. Presumably it was during this period, Nick, that you developed a passion for research, and that brought you back to Swansea in 2013 as a member of academic staff in the College of Engineering. Again, you focused your research efforts on materials, and you set up the Mach1 Centre for Advanced Materials Characterisation, housing state-of-the-art equipment, and you used some Welsh Government funding that you brought in to achieve that. So work in these labs has led to more recent grant success, such as the 1.4 million COMET project, looking at combinatorial metallurgy, and the 7 million Prosperity project, developing rapid alloy prototyping methods. In addition, Nick leads the Additive Manufacturing Research Group and has published at the highest international level. He's also successfully supervised PhD students, many in collaboration with industrial partners such as Renishaw and Sandvik Osprey. Now, an inaugural lecture is an opportunity for the speaker to tell us about their academic journey and their achievements that have brought them to this point in their career. So, ladies and gentlemen, it gives me great pleasure to introduce Professor Nick Lavery, who will reflect upon an unorthodox education leading from mathematics to a PhD in engineering and a varied career in both academia and industry. Thank you. Over to you, Nick.
Okay, the clock is ticking. Luckily, I see many friends and family in the audience, so it's not going to be as painful as I thought it might be. I wasn't quite sure how, not having been to an inaugural lecture, so thank you very much for that introduction, by the way, Mr. Wilkes. I haven't been to an inaugural interaction since the mid-90s. The last one I went to was for Arthur Leese when he did his vibrations, so wasn't quite sure what to expect and to do, to give. Some of these seem to go down the personal route, and others seem to talk more about research. So I've tried to combine the two and use this as an occasion to thank the many people who have helped me get to this point in my life. So I've tried to weave a story together from this patchwork which has built up over the years. And obviously the timing is, I'm going to have to switch the timing off on this, I'm really sorry. I put timing on this, you've got to read it as quickly as I can, because I've done what I've always done, which is to put too many slides into my presentations, and particularly the more nervous I am, the more slides I put in, which is terrible for you guys, I know. Okay, so hopefully the timing is off on that now. So let's get started. Chapter 1, the early years. Enough of that. So I was born in 1969 in Stoke-on-Trent, which is close to Kiel, which is where my parents met, while they were both at university finishing their MAs. I spent quite a lot of time on the phone with my mum the other day, trying to piece together exactly what had gone on from that period of being born in 1969 through till around about 1978, 1980, because we were everywhere. So we travelled a lot. From the time I was born, we moved to Spain about 3 months after the graduation. So in September 1969, we were already travelling down through France to Spain. We spent some time in Spain and San Sebastian, particularly in the Basque Country. And not long after that, we went to Morocco. My father had a job in a language institute there. We were there for a few months, and that didn't work out very well, so we shot back up to Spain. All the time traveling around a lot. I think during that period of approximately the first 10 years of my life, I must have been to at least 4 different schools or more. We must have lived in 4 different countries at least. And we went to Jesuit schools, Catholic schools, international English schools, American schools. Went to school in America. It was a brief period in America as well. So I always thought the schools are somewhere you sort of went during the time you're not at home, and not really, didn't get on my, tried to stay out of trouble. I don't know if you've seen the film Kess, the book. And you got Billy and Kess, and he goes to school, and all he tries to do is he gazes out the window and tries not to get bullied by. Anyway, it was kind of like that, and kind of came back in the 1980s on the way back from the States. I don't know, whatever school it was. Went to school in Saltwood. I stayed a few months with my cousins in 1980. Went to a proper primary British school, and something called 11 plus or something. Completely messed it up, lost. And from that point onwards, I think we all went back to Spain again. And I think I've been told that because I failed the 11 plus, the only thing I'd be able to do was some sort of apprenticeship or something, or, because I failed the 11, all you could do was apprenticeship. So it was kind of set in stone. I don't think you were very happy with that. And it was that point that my parents decided to do home tuition. But one of the things is why we ended up always being pulled back to the Basque Country. And I think some of these photos might help you see why the Basque Country is so amazing. In many ways, it's very much like Wales. It's green, it's got hills. And these are actually photographs from the summer. That's Anameya, which is in Alaba. And the Basque Country is itself made up as a very complex, very old country, made up of basically 3 provinces in the autonomous region, in the Spanish region. You've got Navarra, which isn't strictly Basque, but they like to think of it as being Basque. You've got Vizcaya, Gipuzkoa, and Alaba. And then you've got the French Basque side, which is north of the border. And the French have never really recognized the Basque part as an autonomous region. So Anyway, somewhere else we've lived, so trying to look for reasons of why we settled in the Basque Country, and I think there are kind of a lot of hints in what I'm showing you in the pictures. The coastline is stunning, strong hint. This is Gatherugache, which is not far from Mundaka, which we lived for many years, and San Sebastian, where one of my sisters was born, Andoni. And as I sort of hinted to, the history of the Basque Country is fascinating. So this is a painting by Picasso of the 1937 bombing, which is one of the things that Guernica, which is not far from where we were this summer, and we go back every summer. It commemorates the bombing of Guernica, which happened at halfway through the Civil War in Spain. It was a pretty horrendous period of time in the bombing that a lot of people, no soldiers, it was carpet bombed by the fascist side in the army trying to push the Republicans back. And they were meant to only bomb the bridges and the connection points into the town. But I think it was General von Richter from the German army, who was on the fascist side, decided to test some bombing in their Junker planes and dropped incendiary bombs as a practice run for what was going to be used a lot in the Second World War in London. But it backfired, and they were told not to bomb the town. And they bombed the town, and it ended up backfiring because it actually there was such a horrendous feeling after the war that they it went international. A lot of people were killed. No soldiers were killed, and there was a whole peace movement, and more people actually joined the Republican Army. So they probably dragged the war out in Spain by quite a bit of time. That's where we were this summer. There's some picture of the Casa de Juntas, which is the parliament in Guernica. It used to be prior to Victoria being the capital of the Basque Country. And that, where my family is standing, that tree there, the oak tree, is symbolic of the parliament, sort of quite a democratic way of being of the Basques for hundreds of years. I mean, we're proud of our parliament, but they've had a parliament going back just as far. And they'd come from the different villages and stand under the oak tree, and they'd sort of do their debating for rules and laws for the villages to get on. The tree that was planted in commemoration outside the Houses of Parliament there survived the bombing of Guernica, and but it later then died of a disease. But it life, yeah, that's them standing. What's left to it there. Now I'm aware that it's probably going a long way from my research, so I'm going to try to push through as quickly as I can. So what other reasons for living in the Basque Country? It's an amazing place. The people have some amazing customs. The sports they play, the running of the bulls, you've probably seen that sometimes on the news. Very unique people, very unique place, very friendly people, like the Welsh, to a certain extent. Here's some photographs of what they do a lot is fiesta, so slightly different, on a very different time scale. So you go through time zones to get down there. And when we get there, it's usually to bed by midnight and up at midday. So, and these fiestas have a lot to do with it. You can see them sort of starting their fiestas there. Food, yeah. So another really good reason to love the Basque Country is its food. Anyway, I can tell you lots of stories. That guy there is a very famous chef who we used to know, Carlos Arignano. He had a restaurant in Zarauz, one of the places we lived. I was very into surfing. We surfed a lot. And he had the restaurant there, and he would come out at the end of the day with all these cakes that hadn't eaten for lunch. And we'd have been surfing. We were very hungry, and that was a terrible life. But yeah, no, it wasn't the food. It was the surfing. And that's not just me, as my dad surfed as well. And that's been part of the reason for us going everywhere. I think probably even California had something to do with it when he went to do his PhD. So that's my dad there. And that's me surfing on the left quite a few years later. And that's the wave which is amongst the 10 best waves in the world. My parents moved there to live there, to not far from work, so that I could surf. That was a big sacrifice, but not for me. It's an amazing wave. It breaks off a sandbank. It's got the most amazing shape in the world. So that kind of explains a lot of the different places that we've lived throughout the years. San Sebastian, Zarauth, Mundaka, Baguio, and eventually my parents living in Bilbao, working in Bilbao at the University of Deusto. And I think you can see the pattern repeating, that most of these places are all on the coast where the waves are good. Anyway, let's get back on track. So, home tuition was something that my parents took on after the 80s, after seeing that my brain was going to mush, and I didn't have a lot of prospects apart from surfing, maybe. So we started home tuition in 1980, and my parents took that on board, bought as many books and syllabuses and passed examination papers from the London Board of Examination, and they helped us teach ourselves. And I think that we started off, they taught us, and then after a bit we taught ourselves, and certainly by the end of the A-levels. So I think the grades aren't particularly distinguishing, but it's pretty incredible when you think there was no tutors involved. This is just my parents and us working to do this. Particularly when it comes to A-levels, that's more of an achievement, I think, where you see students coming in with 3 stars, 3 A stars and stuff, but they've had plenty of coaching through the way. This is just us doing this. And they taught us to enjoy it. So there was no Xboxes, no internets, no distractions, apart from surfing. It was just books and reading, and it was enjoyable. But no comments about my figure. And you asked about whether I was modelling or not. Well, once in a while. So there was, again, my parents helped with this all the way through. And I went to one competition on my own on the train with my friends, and I won it. Beat all the Spanish juniors. Came back and said, I told my dad, I've won a competition. He went, I'll get out of here, you didn't. I said, yeah, I did. And after that, he said, all right, okay, we'll go on to these competitions. And I started winning. And I was the European Junior Champion all the way till 1985, actually all the way to 87. But managed to compete in the Eurosurf, came 5th. I was 17th in the World Juniors, 86. 5th in 87 in France. I actually became professional for about half a year. And I was 10th and 22nd 2 years in a row. Anyway, that was going on in the background. So when I wasn't surfing, I was studying or sleeping. Sometimes more sleeping. But there's some photographs from the 87, from the 85. Eurosurf. That's me there, next to the guy on the right, to the left of me with the curly hair. It's Jorge Mbert. He's one of the best Spanish surfers of that era of the 80s. He was the senior champion for many years, and him and I used to go head-to-head a lot on the surfing competitions. But I was publishing before I was publishing. So that's a poster. It was a centerfold in a magazine, Spanish magazines, and one very famous competition at Mundaka, the one on the right, which I was honoured to find that Pete Jones, our local surf shop, had it up in his bathroom on the wall. And he used to tell me that while he was, he would see me surfing that wave. So, okay, sorry, I've gone on too much on this already. But I did intend, so my intention on this was really to thank everybody that's helped me so far. And really, my parents did so much for us, my sisters and myself. You know, I can't even imagine it. Trying to do that myself, if we try to do that ourselves, take the kids out of school, you have to become parents, teachers, coaches, everything. And it's a massive undertaking. And I don't know how they managed to do it with all 4 of us. So, thank you, Mum. Okay, so in 87 there's a photograph. That day was literally when the A-levels came out. and we're smiling. Surf was good, but yeah, that was, our A-levels came out, so we knew on that day that we'd done okay, and that was the end of that chapter, and the new chapter starts, which is when we came up to college. So my first degree, the two of us, my sister and myself, we both had done quite well in mathematics. For various reasons, it was the easiest thing to study from home. You don't need a lab, you don't need anything like that. So we ended up doing mathematics. My love was for applied mathematics. My sister was more in pure mathematics. But we went into the same year to the same college, and that's Girton College. There's some photographs there. And obviously I spent my 3 years there very wisely. So rowed, went to balls, I played water polo, and also I think I'm the only British surfing champion from Cambridge. So I represented Cambridge that year. I don't think that's happened before or after. They're pretty landlocked up there. So, but I may be wrong. There's but this is really the start now of my. They deconstructed us. That was the idea. There wasn't a lot to deconstruct in my case, but my sister got through it very well. And during all that time that I was busy rowing and doing all the things I shouldn't, my sister went to lectures. So if it hadn't been for Danny and me photocopying her lecture notes, I'd not be here now. So there's someone else I have to really thank. But we got to do have some very interesting lectures. We got through it, both of us got through it at the end. My sister did a lot better than me, but I managed to scrape through. But I used to sit next to this guy in the Department of Applied Mathematics. Something very interesting, a tradition they have there is that they, all of the staff have 11 o'clock tea with all of the students. Doesn't matter what level of students you are, they all go out and they sit in the same common room. And we just sort of sit there gobsmacked most of the time at all the postdocs and lecturers and Stephen Hawkins there didn't talk very much. But when he did, everybody shut up. Even the head of college. It's amazing. But I did manage to get through the year. I did find one thing that really took my interest in the last year that I was there, and that was a mixture of computation and fluid dynamics. I love fluid dynamics. I hadn't done computer modeling before, and my first task on one of my level 3 projects was to solve the Faulkner-Scan equation using Runge-Kutta with it's an ordinary differential equation, and I enjoyed it. I would stay up till 1 o'clock in the morning, programming it and looking at all the beautiful flow patterns that would happen, and that geared me up to what I wanted to do for a master's and a PhD. Interesting enough, in 1987, and I'm not sure if I'd mentioned this, when we got our A-level results, a bit of a disagreement between Dad to a certain extent and myself about which university I should go to. I wanted to come to Swansea. My dad wanted me, I think, to a certain extent, to go to Cambridge. And so I came for an interview in 1987, and I was interviewed by a young Nigel Wetherill, who was the head of intakes, and I got accepted. My first choice was Swansea. Second choice was Cambridge. Cambridge weren't very impressed by that, actually. But managed to get back anyway, for obvious reasons. PhD in fluid dynamics, nothing to do with the surfing. And there's a photograph of Nigel next to my PhD supervisor, Professor Cedric Taylor. And he was an amazingly kind guy who helped me through I was his last PhD student, and it was quite a traumatic last year for him, last 3 years with me there, not just because of me, but sorry, his wife died halfway through, so I didn't see him for quite a long time in the second year, but when he came back, he was like, come on, let's get you through, and he helped me, so it was lovely. 1995, still doing a bit of surfing. I actually surfed for Wales, and also I got the Swansea surfing team back on track, and we won the event. I organised it all, put the trials, put the team together, got them sponsored by Billabong, so they got Billabong tops, And we beat all the other Plymouth and all the other big colleges that always win every year. And that hadn't been happened for many, many years. I had my first publication off the PhD. So, postdoc years. So as I said, this is about thanking the right people who've helped me all the way through. My first postdoc, I worked for David Gethin mainly, and this was on my first work. So I moved from fluid dynamics, which I'd done for my PhD primarily. Quite mathematical, programming multi-grid methods and things for in finite element fluid dynamics, and moved into simulation of the powder compaction process. You can see the process there. Powder gets put in a die, and the punch comes down. So some codes, David Gethin in the group, and worked closely with Rajesh there. Rajesh was one of the two, we were two of the postdocs working for David at the time. Yeah, David was always very hands-on. I don't think he really knew how to program finite element, but he was very hands-on. He'd come in and he'd want to help. As soon as he was stuck, he'd sit there and make sure that everything would try to work until it helped. He'd get past any kind of blocks. And he was also kind enough to let me finish off my PhD, which obviously overrun, kind of like my talks. Second postdoc, I went to San Diego because I heard there was a postdoc going there for a year. And again, this was programming finite element methods, looking into using high performance Fortran to solve highly nonlinear structural problems. BFGS, Broyden, I can't even say now, used to be able to say it. Broyden, Fletcher, Gordon updates compared to Newton Raphson were much faster with finite elements. And so I spent a lot of time programming and routing the networks, and of course, surfing. A lot of surfing the year that was there. Yeah, I missed home, actually. I missed Swansea very much on those years that I was there, and I saw an advert for a postdoc at Swansea University and to develop another finite element code but this time for radiative infrared signature prediction in aircraft. It was sponsored by DSTL, a one-year position, and that was the best thing that could have happened. And I was lucky to have PIs on the project were Steve Brown and John Spittle, and I joined their group, which was quite a dispersed group of people working on casting and some solid mechanics and materials, generally materials, but there was either the finite element. That's part of the simulation code there, which is the tail end of a Hawk 100 training jet. And you can see the heating block. And that code was something that we developed on those years with DSTL. And they would then plug that into quite a complex system that would allow them to integrate with CFT codes that they had, and then they would be able to predict what the infrared signature would look like from different angles. And at that time, although this is something which now doesn't seem that complicated in terms of commercial codes like ANSYS, they had a lot of problems with ANSYS getting that to work back in those days. But Steve gave me something which I hadn't had before, I think to a certain extent, which was a level of independence of doing taking my own route through the research. And as a consequence, we took that DSTL contract and extended it through for quite a long period of time. I was almost getting £500,000 out of them by the end of it, and actually renewing my own contract 2 years in a row as a postdoc, which, boys, girls, that's the bar. Okay? Right, so at the end of my third postdoc there, I kind of made a division. Moved away a little bit from sort of independent research to working for money. And this isn't, well, I mean, they used to call it kind of rather contemptuously the third mission in those days. We don't use that term anymore now. It sounds like an e-mission. But Materials CETIC, the Welsh Development Agency at the time, set up these centres of excellence around Wales. There were 20 of them. And we were one of them in materials. Gavin, where are you, mate? There you go. You remember the days?
Good old days, mate.
So a lot of it was not so much, we'd do small project, engineering projects, technical troubleshooting projects. We would try to engage with academics to bring them more into, maybe do some consultancy with the companies, sort of thing that Astute does a lot now of, but probably not as well organized in those days. But at the same time, and thanks to George, and he had a rough and ready way of making us, every Monday we would sit down for 2 hours in the morning and he would puff away with his cigarettes and he'd blow smoke all over Gavin and myself and he'd be telling us what life was all about. But one thing he did encourage us to do, which was to carry on writing papers and doing academic research, even though we had to do the day job. The day job was what the WDA wanted. And that was a valuable lesson, which I've taken through from that point onwards. So, you're an amazing person, George. Gav, we'd have not got through those days if it hadn't been for you. So yeah, Gav had certain similarities with an entertainer. We went a lot of places together. We did a lot of things together, and he always managed to keep us laughing. But one of those things, on one of the trips we went around, I went on to visit David Jarvis at the European Space Agency, who was setting up a project, his first project, big project, called Impress. David had done his PhD with Steve a few years earlier and had been working on putting together this big Framework 6 project, which eventually came off. And that was me meeting him in 2003, not long before I actually went to work with him. And that was my next job as exploitation expert, which I know, when I spoke to Dave about it, I changed that to business manager, but then I put it back to what it should have been. But primarily I was there to work on the Impress project, which was a 41 million project, very big project, lots of partners. That was the main day job, was to be part of the team that supported that. But eventually, as that project was tapering off, we got involved with putting together a lot of other projects. So accelerating metallurgy, which Steve already mentioned, and Amaze. Those are the two which Swansea have been involved with post coming back here. The other ones we didn't have so much involvement with. But of those 5 there, 4 of them were funded, which as a success rate is pretty staggering. And they were well put together by Dave. And I would support him doing things, patenting, looking at the environmental aspects of the metallurgy, the processes, the manufacturing, and anything to do with scaling up from the lab, which is kind of my area that I was trying to develop. Okay, so one of the... Google's amazing. Eh? You can put together these heat maps of all the places you visited as a function of time, and you put your Excel sheet in there. And the traveling in that period was just astounding. So not only did we have all the plenaries from the Impress project, but we're setting up new projects as well. And each of those require workshops, 2 or 3 a year, different places in Europe, in Russia, all around Europe, after the States, the TMSs and all this sort of stuff. And I worked out that I'm in the 5-year period that I worked for the European Space Agency, I was commuting as well from here. So 1 week I'd work here, a lot of our partners in the UK, so I'd drive around, and then the next week I'd be over in Holland, and then we fly around to visit the partners. So over that 5-year period, I must have flown 164 commuting trips. And that was only broken up once by the volcanic eruption from Iceland, which put down aviation for a week, which gave us a break. But on top of that, we did 67 missions, which were all over. So that probably adds up to 300 odd flights. You know, people in business know that. Luckily, we don't do that much anymore. And, you know, I think it's actually really draining. And I don't know how my family put up with it for those years that I was doing it for so long with the kids young and all. But it was pretty exhausting. And that was one of the reasons, I mean, that maybe come back to Wales, but also it was going down the route of becoming quite laborious. And it meant moving over to Holland full time, which I think was not something we really wanted to do. But couldn't thank David more. That period with him I mean, he's amazing. He's just got an energy in him to set these projects up, and I learned so much from him and from the people that we worked with to set the projects up. It got me into materials and especially the proposal writing. So it was a real education on big proposal writing and working on collaborative projects. A huge network of European collaborators that, unfortunately, over the last couple of years has kind of been dwindling a bit. But it's still there. They're still there, some of them. But it got me into additive manufacturing and rapid alloy prototyping, which are the two things which I brought back to Swansea. Again, this is about thanking the right people. And this is thanking my own family, particularly Maya. And in that period, we got married. We had Tristan in 2006, and we had Alice in 2008. And, Maya was always really, if it hadn't been for Maya supporting me through those years, it was really hard, her with the young kids and me traveling all over the place and leaving her alone. So can't say thank you enough. And the kids that, slowly made my life more balanced. Without that, I would probably just be squirreled away doing finite element modeling or something. They came back, an opportunity. So I got the dates wrong there. It should be 2011 through 2013 as a technical manager in Astute. And this again was another learning curve. I'd never managed people before. And it wasn't pleasant to start off with. But we ran a lot of projects in that first tranche of money from Astute, and a lot of dealing with some of the things I'm comfortable with IP, but also managing the projects. But at the same time, still had freedom, and the freedom to do some research, the freedom to write some papers, the freedom to, do a bit of our own stuff. Supervision of MSDs, learning how to do that, and MSc students, that went on. So I wanted to thank Hans as well for that period of time, because he supported me a lot during the time working in Astute, and since as well, always. So a very big thank you for that, and for all the encouragement to apply for staff and everything right back in 2013. It's great, I get to embarrass everybody else. See, I did that? Yeah. So, honestly, it's been, I'm talking about a journey here that while you're doing it, you don't know you're doing it potentially right. I didn't know. Coming back, I thought I wasn't doing anything right. Publications were pretty low. I know I've been involved with big projects, but what did that count? They're not my project. I wasn't running them anymore. I didn't see them through to the end. But yeah, I did learn how to do that stuff. So I wrote big proposals and did my own. I didn't know how to conduct research. I learned how to supervise students a little bit, and how to manage teams and do engineering work, and that was quite a challenge. So that original advice from both Steve but also from George Wilshire was incredible, because I did continue to try to do some publications, and this is the tip. Even though you should always try. Even if it's Excel engineering or review papers or something, you can always read and write. And teaching. I did a little bit of teaching, which wasn't even strictly part of the job. Right. With 5 minutes to go, we'll get on to the research. So I've got to mention teaching a little bit, because actually, not just because students pay 80% of our salary. Is that right? Right figures? Yeah. It's a change of culture, very different to when a lot of us were students and kids. So what I say doesn't necessarily go. It's not that way around there. But the client model doesn't particularly work very well. But we have all these metrics, and that's another thing to get used to. Is all these different metrics. I've been teaching mainly in mechanical. I came on and took on 2 big modules, 269 and 324. Did 269 for 1 year and 324 engineering practice I've been doing ever since. And now Spencer's got it. and he's doing a fantastic job having taken over from me. But they are challenging, big modules with grumpy students who think that they're not getting enough hands-on in their experiments, and which is actually very true, but very difficult to do anything about, because you have 250 students trying to do 5 different experiments in a crowded lab, and how you get them to do something hands-on, it's difficult. Rajesh, we know about this. When we've thought about it so many times and how we can change it, and we go back to what we can do, because it will take a year or 2 years to implement the changes. So it's actually very difficult. Obviously, I supervise level 3 projects, as everybody else is. It always includes a formula student project. I've always put a formula student project in to support formula student. Not always a formula student, but always doing something with additives to support the building of the engine and the car. And in particular, one piece here, I'm going to get on to the additive, which is my part, but this intercooler here, which was designed and made by Dan up there when he was in his level 3, and Catherine, and it actually became a Renishaw case study. And you know, they were very impressed with the part and making it. It didn't get tested. A bit too advanced for Formula Student at the moment, but maybe one day. And then, of course, postgraduates. So anyway, quite a few postgraduate students. Here I want to say thank you to Dave. And I hope you're taking lots of tips today. Yeah? How not to do it? So Dave's been amazing because, you know, he's so always cheerful. That's what I love about Dave, that, you know, whereas all of us might have a bad day, he doesn't have bad days, really. Yeah, that's quite a relief when you walk down the corridor. Some students being, oh, no, I don't think it's working, it's not working. And Dave's like, don't worry, it's fine. But yeah, they're starting to go through now. So I have had a rather large load of postgrads and some really good students. 3 sponsored by Renishaw, Dan up there who's still sponsored by Renishaw as well. Steve Millwood, I'm not going to mention all of you. Steve, get finished. And Stuart, yeah, I'll come to Stuart in a minute when I actually go on to the research part. So one of the things that we have to do is our certification that we can actually, we can teach, and then we thought about teaching. So one of the things I found actually quite hard from last summer, this took a lot of time putting together, even though you may have done it in your class while you're lecturing and you're putting in new methods of teaching, flipped classroom, blended learning, videos, you're recording, you're putting it on Blackboard, you're trying to make Blackboard, you're trying to make it interesting for the students and sometimes trying to teach them without them actually realizing that they're absorbing more than they actually think they're getting. Trying to put all of that together, but actually summarizing that is quite a pain. But thanks to Andrew very much, I should say Diolch, without this, he helped me through get the HEA last summer, and I thought I'd read a little bit of the caption there that Steve put in on the reference. You need 2 references from staff. I had one from Andrew and one from Steve, and I like this one. Funny. Nick is a funny and humble man. Okay. I have tried various things. I've tried flipped classroom, which was an absolute disaster. Our blended learning is okay. That's fine. They like that. That's not a problem. The flipped classroom was, I had to switch that off after about 3 weeks into term. Now, I don't know, either I didn't get it or they didn't get it or we both didn't get it, and it didn't work very well. So I got criticized for that, although one student actually thought at the end, okay, I can see this, what you're trying to do. Get us to come in, watch the videos and come into the classroom and then answer a group test or something like that, you know. Yeah, but we went back to kind of half and half. But one thing that I've always done is bring in a practical element. I've tried to keep it practical. You can see some of the parts here on the front that have been designed and made, not made by the student, designed. The making is done by the gentleman at the back who can actually work the machines. these are my PhD students and postdoc. I would not let some of the undergrads loose on our AM equipment. It would be a very expensive problem. But these are some of the good comments that have come from it. One thing in particular is that Sandvik, Keith Murray, and other people we work with have always come in and supported us very much by giving lectures to the students, and they like it. They like to have somebody coming from industry to give them a different perspective. So I'm going over time. 5 minutes. I've got to give you some research to take away with you. So I'll go through this relatively quickly because all of you are here. You all know me. If you want, and you know what I do, mainly. And if you want to come and find out more, you are welcome to come to my office anytime you want. We're basically divided into 4 areas as we came back. We've got, some of these have labs associated with them. This is materials characterization, Mach 1. Combinatorial metallurgy, or rapid alloy prototyping. Additive manufacturing, those parts there. And you see the process in action and one of the end parts there as well. And then computational modeling of pretty much everything that we can simulate, whether that be anything with casting or whatever. But particularly at the moment, we've been concentrating on the simulation there. And this is some of Jordan's results from his conference this summer. Mach 1 we set up in 2013 thanks to A4B funding, which Terry Stubbs helped us get and put us through. And what that has been something else to have that, an amazing foresight. And I hope your colleagues realise that as much as us. Yeah. So we set up primarily to high throughput thermophysical property measurement, and we did our first setup of the rapid alloy prototyping kit with the help from Astute. 2015, obviously, we all moved over to the Bay campus, and that meant setting up the labs for a second time. We went into the pilot line where we had about 100 square meters through 4 different labs. Materials characterization lab, the alloy discovery lab, the additive lab, and the metallographic preparation lab. All of this with a lot of equipment. And now we're going through hopefully the third and final move to Engineering North Impact Building. It's a beautiful new building right next door to us. We're in the stage, we've moved all the offices. Steve's next door to me upstairs. Lovely building. Labs are amazing. We've done a lot of work getting those with Gavin and with Greg, getting them all ready well in advance. So we've got the new Mach 1 lab enclosed there, and next to it is the ALM labs. There's an open area on the outside, which is we've dedicated for our rapid alloy prototyping for steels. I'll talk a bit more about that later on. Yeah, so some of the equipment's going in, so the boys have been working hard getting some of the equipment in over July and August. So I'm going to try to get through this as quickly as I can. I'm not going to go through these. If you want to see that these are the centre missions, what we intend to do. A lot of it working with industry is one of our core aspects. The equipment we have you might be interested in, because it's a thing which collaboratively we can share out and use, which in impact. Temperature-dependent thermophysical properties to high temperature, things which measure everything from thermal diffusivity to thermal expansion, electrical resistivity. Mechanical properties, we work with powders a lot, and obviously the rapid alloy prototyping, we've got some new equipment in, which the guys have been getting working today, which is a 200-gram centrifugal caster, and that seems to be working quite nicely. As part of the Prosperity Project, we should have hot and cold rolling in place. We've been also getting our composition measurement kit going. So we're working on a Brooker, which Tata have lent us for the duration of the projects. And also we've got Leco and Ultra, which we bought from Sandvik, which we're just about getting ready to work now. Funding and grants, so over that period, a lot of different funding applications, not all the successful ones in there. So us applied for over 18.4 million, where I was part of the application, of which 4.75 were successful. About 1.5 as PI, co-PI, and 3 million as co-I. So the important ones, which are still running at the moment, are Comet and Prosperity. We have some funding from DSTL as well, where up there for Ewan, who's working on corrosion on additive parts. One of the key papers that we published in 2015 with, just note some of the co-authors there. So David Jarvis from ESA, Wayne Voice, who was working at ESA at the time on accelerated metallurgy, and Martin Brunnock from Tata. Martin Brunnock was at the time technical director of Tata in steel in Europe. Wayne Voice had been Rolls-Royce manufacturing expert, and David Jarvis, obviously I've spoken about him already. So that was quite a pivotal paper in terms of rapid alloy prototyping. It's not been cited once, but I don't particularly care at this point. It's a bit of a shame, but for us it was an important paper because it showed that we were doing that, and it's led to Prosperity, big project, which I'm going to talk about now. Big thanks to Terry, again, there, who helped us for the original funding for Mach 1, which has led to all of this. The Comet project, second Welsh Government project, is part of the Smart Expertise, which is running at the moment, and it funds Dr. Mehraban and Jonathan and Steve and Ravi. We've got 4 postdocs on that. So this is started April 2018, 3-year project. With Sandvik, Dr. Martin Kearns is there, and all of this is it's quite an interesting project. We've got a lot of things going on there. We're working on additive manufacturing, rapid alloy prototyping, and modelling there. Again, I'll talk more about it. Just a quick thanks there to Cameron, who's also part of the PI in the project. And when it comes to rapid alloy prototyping, and metallurgy, he loves it, and he's a real inspiration to have on any project. Prosperity started last year as well, later on in November. This is a big project, involves Warwick University, ourselves, Sammy in Singleton, and Tata, obviously. So we're taking rapid alloy prototyping and seeing how far we can take it. And I think that is, rapid alloy prototyping has existed for a while, but whether it's such a difference in scales between 300 tons that get melted in Tata on strip down to 20 grams you can make. Can the speed be used not just to replicate the composition, but also the microstructures and the mechanical properties at that scale, and whether that can give you useful information to scale up so that you can go through rapidly lots of different samples? Can it speed up the development of new alloys, of new products, and improvement in products? So this is quite challenging, and it's something that we're working on. Again, thanks to the entire team, especially Shaheen. Without Shaheen, there would be none of the equipment would work, the labs wouldn't work, no one knows what's going on. So honestly, so I'm not going to go through all the additive. I've run out of time now, and I'm really sorry. I've gone over additive manufacturing. See some of the parts that are made here. It's what we can make. We've done a lot of work modelling this and also developing experiments. The modelling is extremely complicated. We've got lots of different multi-physics going on there, radiation, lasers, porous powder, conduction, Marangoni, convection. It's beautifully complicated, but the modelling only gets you so far because nobody really believes the modelling because it can tell you anything. So the best way is to say, maybe at the larger scale, modelling is good, but really you want to be able to do experiments to verify, and doing those experiments is incredibly tricky. These things are like black boxes. We only have so much access. This is some of the work from Stuart up there, who's now working for Sandvik, and he finished his PhD last year, NGD with us last year, and he developed this 3-prong method, and it was given a prize of this paper in the SFF in the 2017, and went directly into the journal. And this 3-prong method is a way of looking at the residual stresses, which are one of the problems that you get with these parts in additive manufacturing. A lot of work that we've done with Sandvik, and Martin and Keith at Sandvik is looking at how powders, how they age, how much time can we get out of the powders in the machines. Some of the applications of additive manufacturing. So this is the Innovate UK project we ran with Zeal, who make these bike clocks. And we're using the additive manufacturing to make working prototypes so that we were able to almost double the strength out of the locks. And they're not going to use additive manufacturing to make their parts, but it helped them make better parts, which will be cast anyway. And they are looking to use it again now for another project. The big one that we ran, and this is the one that I'd hoped that we'd be able to present more of, is working on space components. And this one is working with Thales Alenia for the best part of 9 months for low thermal expansion alloys for this space bracket. And just some final words. I told you I'd rush through the research. I can see you all of it. Any time you want to come and see me, come and talk about any of this. Right, so I got part of the title from a quotation from Hemingway. Hemingway liked to spend a lot of time. He fought in the Civil War, didn't he? Yeah, Mum knows more about this than me. But he loved the Basque Country as well. And that was, it is good to have an end to a journey, to journey toward, but it is a journey that matters in the end. Now, I had hoped in my naivety to make some connection at some stage between mathematics and metallurgy. So modelling, we don't consider mathematics in the mathematics world. Modelling is modelling, mathematics, pure mathematics. That's the place where, you know, if you're going to make a... And there's a lot of that does go on, but it's fair, it's up here. That's left for the big idea, hopefully. Now, the one thing I have learned is collaboration and people are key to the success of research. And if we're to address some of the challenges, we have to collaborate between disciplines, between universities, and act as coherent groups. And I think we're well set at Swansea, and that's the thing. We're well kitted out. I know it's a turbulent period, but we have some amazing laboratories, some amazing things going on, not just with our labs, but I think you could see us contributing to this over the next 100 years. So a lot of what I've got and had has been a lot of luck, but I've also worked hard, not always cleverly, and if I can do it, then anybody can do it, whatever background. Doesn't matter if you're a mathematician, a physicist, or whatever. If you're interested in engineering, you can do it. So if I've missed any of you, and I haven't thanked you, which I think I've thanked everybody, I'd like a big round of applause for all of you. Thank you for coming tonight. That's for you. And just one final word of thank you for Steve, just to really embarrass you. Okay, so Steve, a research partner and mentor, and obviously a friend, and probably the best head of college, but we'll see. So the new period's began. Steve's back in shorts, working in a dark room. I'm not sure what exactly, but am I going to be your line manager?
Yes.
Right. When's the next paper out? All right, thank you very much. Sorry.
Okay, so I'm Professor Hugh Summers. As Nick alluded to, I'm the new head of college. And actually, this is the first sort of formal occasion I've had to attend. So, what better one? It's really fantastic as the first one to welcome a new professor to the college. Fantastic. Nick had the unenviable position. This whole idea of having lecturers from new professorial staff. I understand it was a tradition in Swansea and it fell by the way, and so yours is probably the first inaugural talk by a professor in engineering for 20 years or more, I think. I'm not embarrassed to say you might be in the last one.
Thank you.
So thank you, Nick. A fantastic talk. The quote you had there, is a funny and humble man. Your talk exemplified that. You went through all of these people who you acknowledged and helped on along the way, but you really quite downplayed that your achievements have been fantastic, and I think for all of us, we would all agree that welcoming you in as a professor now into the college is fantastic, and much deserved, and it's clear the evidence is overwhelming. It's clearly why you should be there. So I also wanted to particularly thank you for giving a very personal view and being willing to share with us quite a personal trip through your career, and that's I feel certainly privileged, and I'm sure the rest of the people will feel that. It's for you to be able to and willing to share that with us has been fantastic. So although we skip through the research, but for me it's really much more enjoyable and interesting to really hear about people's lives and hear how you got here. So it's fantastic. So I want to thank you for a wonderful talk, and I'm sure the success you put up, and I haven't allowed questions, but I'm sure, and afterwards I want to ask about some of these things. I'm sure afterwards there'll be time for questions. So I'm going to ask us to all give Nick a round of applause in a minute and finish up. I want to finish by saying I think the only thing that is missing now is an image of Professor Nick Lavery, ex-professional surfer, on a wave outside the Bay campus.
I don't. At the moment, they don't make boards big enough. But watch this space next summer. I'll be ripping those little 2-footers up. So. And there is already a consortium of professors that go surfing. You know that? Yeah, they got a little handshake and everything.
For anyone who, at the moment, so like there's least one person here who will be giving talks in the coming year for their inaugural talk, you don't have to wear the hat all the way through.
Oh. Now you tell me.